All right, so our first problem is right here. Lily and her family want to reduce their electricity. They're telling us that in August, they use 1,156 kilowatt hours of electricity. And then the very next month, they did reduce it. They went down to 1,018 kilowatt hours of electricity. So how can I figure out how much less kilowatt hours they use? Okay, let's go ahead and do that. 1,156 minus 1,018. So that's easy enough. How much less kilowatt hours they use? 138. They use 138 less kilowatt hours. But we saw yesterday when we were talking about the taco truck and the prices of tacos, we could just look at the increase being 25 cents and 75 cents. Or what's the other way that we could look at the increase? By percentages. So it's the same thing with this. Yeah, we could say that they went down 138 kilowatts. Or we can figure out what the percentage of that decrease is. So our next problem. And this is just for you to think about. I want you to write an answer down. It says, Lily is proud that her family now uses less electricity. So she decides to share the results with her classmates. She tells them, if we conserve electricity at school, we can also use about 138 kilowatt hours less of electricity each month. What do you think of Lily's statement? Now, I don't want you to answer it right now. I want you to write an answer down on your book, and then we can talk about what you think about her statement. What do you think about Lily's statement? Can somebody give me an answer of what you think about Lily's statement? Yes, ma'am.
I think it would have because the schools are bigger than it would have more.
Okay, how many people agree with Jen? She said she doesn't think it would be right because the school is way bigger than Lily's house, right? So do you think the amount of electricity they can save, do you think it's just going to be 138 kilowatt hours? Or do you think it'll be way more than that? Way more than that. Okay? And that's the perfect answer. Thank you for that. I had other people telling me, oh, I don't think it's true. Last hour they were like, I don't think it's true because the school's got a lot of lights and smart boards and electricity and air conditioners.
Who said that?
At least 3 of them.
During the weekend, the lights are off, right?
Yeah. As the lights are off between 3 o'clock and 8 o'clock.
Yeah, and
Yeah. But because of the size of the school, I'm pretty sure if the school, everybody in the school really tried to save electricity and turn their lights off when nobody was in the room and turn the electricity off. I don't think this one does.
Okay, so listen.
But okay, we're not talking about generators. We're talking about actual normal electricity.
Yeah.
The school can save a whole lot more electricity than somebody could at their little house. Okay? So let's talk about this problem as a percent. We know that Lily's family saved 138 kilowatt hours of electricity. But now, part B says, by what percent did Lily's family reduce their usage of electricity? And they want us to round to the nearest percent. It's going to look a lot like yesterday, all right? Yesterday, we had to find out, if they wanted us to find the percent increase, we had to figure out how much it increased by, and then divide it by whatever the original number was, right? Today's going to be the exact same thing, except now we're talking about a decrease. So we first have to figure out what the decrease is, and then divide it by whatever the original was. So it's pretty much the same exact thing. So let's figure out what the decrease was, even though we already did it in part A. We did 1,156 minus 1,018. That's how we got 138 was our decrease. So we take that decrease, 138, and we put it over our original. What was our original usage?
1,018.
I'm sorry? 1,018?
1,156.
Why is it 1,156 and not 1,018?
Because that's what they use in August and that month.
That's what they used in August, right?
Yeah.
What comes first, August or September?
August.
So that's our original bill. August is our original bill. So we go ahead and put 1,156.
I didn't want to see if you knew that.
So what math problem do we have here? Division.
138 divided by 1,000.
We're going to do
$1.
138 divided by 1,156. Can 1,156 go into 138? Add our decimal, put our 0. Decimal comes up top. How many times? How many times does 1,156 go into 1,380? So now we're looking at 1,156 going into 2,240. How many times do you think that goes? Twice? I'll try twice. 1,156 times 2. Does that work? Nope, too high. So let's go ahead and keep it at a 1. And I only need one more number because it says to round to the nearest percent. So if we move this decimal back 2 places, that would give me 11%. But I need one more number to see whether I got to keep it at 11 or go to 12. So what's the last number I should try? How many times do you think 1156 goes into 10,840? Probably 9, yeah. So 1156 times 9. And 10,394 works for us. So I'm just going to put 9, and I ain't got to worry about the remainder or anything like that. I'm going to take that number, put it right on over here, 0.119. We want to make that into a percent. Move that decimal 2 times. What percent would it be? 11.9%. Or it says round to the nearest percent. So what are we rounding it to? 12%. They saved 12% at their house. Any questions how we got that? Does that not look exactly like what we did yesterday with the increase, percent increase? It was the same exact thing. Okay? There's no questions about part A. Let's go ahead and take a look at part B. The only difference with that one was instead of figuring out what the increase was, we were just figuring out what the decrease was. That's all. Everything else was done the same.
How did you do that?
Part B. Lily's school used 70,520 kilowatts of electricity last month. Obviously, a whole lot more than Lily's house used. And it says the school makes a goal to reduce its electricity usage this month by the same percent that Lily's family did. How much electricity can the school use this month and still meet its goal? Round your answer to the nearest appropriate kilowatt hour. So, looks exactly like what we talked about yesterday again. Yesterday we had to find a percent increase. And then another type of problem that we had to do was, here's some information. Here's a percent that they wanted to increase it by. Figure out what the new taco price is, right? Same thing right here. We figured out that the percent decrease at Lily's house was 12%. Now they're telling us, hey, the school wants to make a new bill. They're using 12%. They want to reduce their stuff by 12%. Okay? Be the same stuff. We can see if we're doing it the same way. So, how do y'all want to go ahead and do this problem?
I think we should do 12% times 70,520.
So that if we do it that way, that sounds like you want to use part was equal to percent times the whole. which is one method that we could have did our problems yesterday. Do we know our part? No. No. The part, just like yesterday, the part, if you did it that way, that would just tell you your increase. Like when the girl wanted to increase the price of her salsa, and we did part was equal to percent whole, we figured out that her increase should have been 35 cents. Then we had to add it to the regular price. Same thing with this one. Our part for this problem is how much they're decreasing it by. Do you know your percent? What is it? 12%. The school wants to decrease their usage by 12%. Do we know our whole?
Yes.
70,520. And the answer to that is no, I don't. So we can go ahead and move that decimal 2 places. That's going to give us 0.12 times 70,520. We go ahead and do that problem. So that means that the school wants their light bill to go from 70,520 kilowatts to only 8,462 kilowatts. Y'all agree with that statement? They want their bill to go from 70,000 just to 8,000?
No, that's how much they wanted to decrease.
That's how much they wanted to decrease. So how much do we figure out how much they want to set for a goal? Okay, so we take our original 70,520 and subtract the decrease that we just found. They want to decrease it by 8,462.40. Remember, when you subtracting or adding decimals, you got to line them up. So I can't take 4 away from nothing, so I got to add some zeros up here. That'll be 0.
Probably see all this and not do it.
You want to sit right there just so you can not pay attention and not do anything? That's what it looks like you're doing right now. So they say to round it to the nearest kilowatt hour. What number do y'all want to round it to? Anybody? We want to round to the nearest 1.
You can make that an 8.
So it'll be, make it an 8. So 62,058. Okay, so they want their bill, or they want their usage to go from 70,000 down to 62,000. That's their goal. Was there another way to do these problems yesterday? No? I didn't give y'all 2 methods yesterday?
12% plus 100%.
Thank you, sir. We could have done yesterday if we were increasing. If we were increasing, we did 100% plus the 12% increase. Or 100% plus a 20% increase. Then we just had to do one math problem. We multiplied and we were done. We got our answer. There was no finding the increase and then having to add it to the original. Same thing today. We have 2 methods that we can do right here.
I know what you can do.
Great. Keep it to yourself because I'm teaching it right now. So this is a reduction. We are decreasing it. So think about it this way. If this was their entire old bill, this whole thing was equal to 70,520, but they wanted to reduce it down by 12%. Here's the 12%. They want to take that off. What percent of the bill of the usage do we want to use?
The rest.
The rest. So we got to figure that out first, right? So let's do 100% minus the percent that they want to take off. So they want their usage not to be 100% of what it was last month. They only want it to be 88% of what they did last month. So just the opposite of what we did yesterday. Yesterday we added 100%. Today we're subtracting the percent that we want to decrease from 100%. So now all I need to do now is say, okay, well, 100% minus the 12% I want to get rid of, that's 88% of my original. My original was 70,520. Move that decimal 2 times. That's going to give me 0.88 times 70,520. So that's the only problem I need to do. Let me go ahead and make myself some room to do that. So 70,520 times 0.88.
You good?
Just go to sleep, bro.
And the answer I get is 62,057.6. Is that the same exact thing that we got the last time?
Yes.
Technically,
Yeah.
that's when you round it.
Before we rounded it, right. But I can round this one to 62,058 as well. So you can use part is equal to percent whole if you feel like it. You just need to remember that you have to then subtract if it's a decrease from the original or add to the original if it's a increase. Or you can do it the other way where you add 100% to whatever the percent is they want to increase for an increase. Or for a decrease, you subtract with the percent that they want to decrease from 100 and just multiply. Completely up to you. Any questions? Everybody's good with both of these methods? Both of these methods,
Yes, sir.
finding percent decrease and all that good stuff.
Yes, sir.
All right, so now I just need you to take care of the next problem on your own. So we're looking at problem 4. And it's going to cut me off. But problem 4 gives you 3 different appliances or household items. It gives you the usage of a light bulb, the usage of a washing machine, and the usage of a dryer. They give you the old model, which is the standard model. So for instance, the light bulb used to use 60 kilowatt hours, but then they got a new energy efficient model that only uses 10 kilowatt hours. They want you to take all 3 of these appliances and figure out what is the percent decrease for each one. Okay? And we are rounding to the nearest whole percent. All right, let's go ahead and talk about these answers to number 4. We were trying to find the percent decreases for each one of these appliances. Does anybody want to share what number they found for the light bulb? Cameron, I saw you first.
83%.
How much?
83.
Anybody else got 83%? The correct answer is 83%. Does anybody need me to show you how we got 83%? I'm going to do it anyway. So, to find the percent decrease of the light bulb, the first thing we need to do is figure out what is the decrease anyway. The old light bulb used 60 kilowatt hours. The new light bulb uses 10. That means the decrease is 50. So we take our increase, I'm sorry, not our increase, that was yesterday's lesson. We take our decrease and put it over the original. This is our math problem right here. 50 divided by 60. When you do 50 divided by 60, you're going to get 0.83, and it's going to repeat. You move that decimal 2 times, and that's going to give you your answer of 83%. I know some people are not that good at division. Does anybody need me to do the division problem to show you how we got 0.83 repeating? No? Okay. So after the light bulb, it was the washing machine. Does anybody have a percent decrease for the washing machine? Yes, Millie. 45% is super, super close.
I got 44.
44% is right on the money. 44% is the correct answer. 44%. So, oh, she blaming it on Cooper.
It is. He did that one.
So for the washing machine, here's the work for it. You're going to go ahead and take the old washing machine, which was 560, subtract the new washing machine usage from it. That's going to give you 244 for a decrease. So your decrease over the original, 244 divided by 560 is going to give you 0.435 for an answer. You move that decimal 2 times. That's going to make it be 43.5%, but they wanted to round it to the nearest whole number, so that's going to be 44%.
Oh yeah, let me tell you the guy.
On this one, does anybody need me to do the division? Cooper?
No.
Everybody's good? Anybody?
I think you just don't know how to round.
Okay. Do the division? Okay. So it is going to be 244 divided by 560, our decrease divided by our original. So obviously 560 can't go into 244. We still got talking going on. I'm going to add my decimal and my 0. 560, the 5, goes into the 24 4 times. I went ahead and did the math off to the side. So 4 times 560 is 2,240. When we subtract that, that's going to leave us with 200. You're going to bring down a 0. And then we got to look to see how many times 560 goes into 2,000. I did that one as well. It's obviously not 4 because 2240 would be too high. So I went down 1 to 3. 3 times 560 is 1,680. When you subtract that, you get a remainder of 320. We do need one more number so that we can round to the nearest whole percent. So I went down and brought this down. And then I looked at it and I said, well, 4 is not going to be enough. Let me try 5. And when I tried 5, it worked out. It actually gave me 2,800, but I don't even care what the remainder is. These are all the numbers that I need. So move that decimal 2 times. That's how I got 43.5%. And then you round it up to 44%. Good?
Actually, he just don't know how to round.
Oh, Cooper knows the division. He just don't know the simpler thing, rounding.
I rounded it. I got it correct. You got 45. My dad is 44. You told me 45. I told you 44.
So how you just say 45?
He just called you a boy.
The next thing we got is the dryer. Does anybody want to share the percent decrease for the dryer? Does anybody want to share the percent decrease for the dryer? I know Cameron wants to do it, but he already gave me one. I'm looking for something from somebody else. Go ahead, give me the answer. You gave me 2 of them. You're right.
I can do
Great,
that.
Lacey, give me the number.
I didn't give you one yet.
And you just said you wanted to do it?
Mr. G, I
Okay.
know who next.
So for the dryer, 34% is the correct answer. We take the old dryer usage, which was 2,790. All right. So now we're going to move back to our regular spots. If I continue to hear talking, I'm just going to go ahead and mark those people. So for the dryer, we had 2790 was our old dryer. Our new dryer only uses 1850, which is a decrease of 940 kilowatts. Take that decrease of 940 and divide it by the old dryer, which was, again, 2,790. When you do that division problem, you would get 0.336. When you take that and turn it into a percent, it would be 33.6%. And then we round that to the nearest whole number, which would then be 34%. Does anybody need the division for that problem? Okay, then. Moving right along. In that case, problem number 5. Waiting on somebody to finish writing. There we go. All right, so problem number 5 says a salesman says that replacing a 30-year-old refrigerator with a new energy-efficient refrigerator reduces electricity usage by 75%. The new energy-efficient refrigerator uses 350 kilowatt hours of electricity per year. How much electricity does the older refrigerator use in that time? So we're not looking for the percent decrease. We're trying to figure out how much was the old refrigerator. Do you think the old refrigerator is the part or the whole?
The whole.
It would be the whole because it's the original. So if you want to use that method, go for it. Remember, this is the type that you got. If they give us the percent, there's really 2 ways to do it. I want you to tell me what the old refrigerator, how much electricity it used in a year. How we got the wrong answer. I know how some of y'all got it because I know right off the bat y'all did the same thing as most of the other class did. Y'all did part was equal to percent times the whole. You said that the part was the new refrigerator, which it should be, 350. You put your percent at 75%. You put a W right here. You change that to 350 and 0.75 W. Divided both sides by 0.75. And when you do 350 divided by 0.75, you would get that 400 something number. You would get 466.7. Don't copy that down because that's wrong,
Where
right?
did you get 76 from?
Huh?
Where did you get 76 from?
What you mean where I got 76 from? It's 75. My 5 is just messed up. It messed up a little bit. Okay? That's how people in the last, we had like 5 people to get that answer. But that's not the right answer. One of these numbers has got to be wrong. Do you think they, I don't know, made a mistake with measuring how much the refrigerator was using? You think 350 is wrong? I don't think 350 is wrong. Do you think 75% might not be the right percent to use?
It isn't.
That's got to be it, right?
It's probably 25%.
Why would you think it'd be 25%?
Because that's the decrease. Yeah, that's the decrease.
So, to try and show you what this should look like, I'm going to go ahead and use a tape diagram as a model. This tape diagram is our old refrigerator. This is the old fridge.
Oh, my answer was right.
Okay? Do you know how much power the old refrigerator used? No. That's what we're trying to find. That's our question. How much power did this old refrigerator use? The only thing the problem tells us is that it doesn't use 75% of the electricity. It says, you know what? This right here, and this right here, is that 75% of this tape diagram? Mm-hmm. Yeah, 3/4, right? So the new refrigerator doesn't even use all of that at all. It only uses this little piece right here. This is the new refrigerator. This is only 25%. And that 25% is equal to, it uses 350 kilowatts. So what we should do in this problem is do 100% minus 75% and get 25%. Then we can go ahead and do part is equal to percent times the whole. Our part being the 350 kilowatts of the new refrigerator. Our percent is it only uses 25%. This 25% and that 350 got to go together, which if you look at the tape diagram, it does. And then you do times the whole. So 350 is equal to 0.25 W. Divide both sides by 0.25. If you need me to do that division, I can, but it ends up being 1,400. And that's our whole, aka the original refrigerator. Yes, ma'am. Anybody need me to do the division problem?
No, sir.
Yeah. I'm trying to do it small down here. So this is 350 divided by 0.25. You asked me to do it, you're talking to Taj instead. .25 would go outside the house. We can't have a decimal outside, so we got to move that one twice. So we got to move this decimal twice too and add those two zeros. So it's going to be this. 25 goes into 35 one time. It's a remainder of 10. Bring this 0 down. 25 goes into 100 4 times. Then you would bring this 0 down. That's 0. You would bring this 0 down. That's 0. That's how you get 1400. We'll see. Any questions on this problem? This is how we're doing it. I want to do one problem at a time. We're actually a little bit ahead of the last class because the only thing we got left to do was we was able to do 6A, and that's it. But now we getting ready to do 6A together right now. Not together, but you can take care of 6A. We'll go over that answer and then keep them moving. So y'all ahead of the game right now. We might not have homework. So switching from electricity now. We're not talking about the electric bill. Now we're talking about the water bill. In August, Dylan's family used 11,587 gallons of water. They make a goal to reduce their water usage by 9%. They're trying to drop it down 9%. They want to figure out what's their goal, and then did they meet it if in the next month they use 10,660. Okay? So let's go ahead and figure out what their goal, what their number they should be hitting is. You're not using 10,660 in the problem. That is just you got to find your number and then compare it to that number. You can do this problem. It says that they want to reduce their usage by 9%. So we could just figure out what's 9% and subtract it. And that would be considered using part is equal to percent times the whole. We want to figure out what their reduction would be. They want to knock it down by 9%. And their original bill was 11,587. If we go ahead and change this to 0.09 and then multiply it times their old bill, we got two numbers behind the decimal. That would mean that they need to reduce their water usage by 1,042.83 gallons of water. So to figure out if they met their goal, we take the 11,587 and subtract the 1,000, my decimal's in the wrong place, 1,042.83. I get that their goal should be 10,544.17.
I'm off. I got 11,426 in front.
Yeah.
I got that. I just hit doors. Oh, I didn't know we had to subtract it.
Again, we've been talking about this for 2 days now. If you are going to forget to add when you're doing an increase and you're going to forget to subtract when you're doing a decrease, you should be doing it the other way, where for an increase, you add the 100%. If I was doing this problem the opposite way, what I should have done, and the way I would do it, is this way. Oh, they want to reduce it by 9%? What's 100% minus 9%?
100% minus 9%.
Is how much?
81%.
Try again. 90. 100 minus 9 is 91. No, the problem's on the board. It's 91%. They only want to use 91% of the water that they used last time. So 91 times 11,587, their old bill, they want to use 91% of that, comes out to 10,544.17. Does anybody have any questions? I'm going to let you just do your own thing now. Now, it means you responsible for taking care of the rest of the problems. And the exit ticket. And then we'll go over it tomorrow.
The rest of the problems in the lesson.
No, the rest of the problems in the book, Cooper.